All right, good evening, everybody. We're about ready to get started. It's my pleasure to introduce Jeana Ripple tonight. This is our second to last lecture of the semester. We have one more lecture next week with Lois Weinthal. And so Jeana is joining us from UVA, where she's an assistant professor and she's the director of the graduate program there. She's going to share some of her work tonight, but I think what's really exciting about bringing Jeana is the fact that she's a 3+ architecture student, or that's how she was trained. Before she was an architect, she's a computer scientist. And so she can share stories about being a computer hacker and other types of things, but I think that training before becoming an architect really informs some of the work that she's doing now, which deals with advanced technology, but also with materials. Jeana's worked in Chicago for Studio Gang Architects, and now she has her own practice called Ripple Architecture Studio, still? Okay. But she's also just launched a new firm called Dear Collective with partners in Chicago. And so some of the things that we were talking about tonight is just what it means to be practicing now, and the discussion about our online degree and the fact that she practices from Virginia, but with partners in Chicago. And so that's the way that she's practicing, is a collaborative practice where a majority of their conversations and a majority of their work occurs online as they do that. So I'll let her share some of her work. She's working on a book, she's working on a project. She's going to show some of the Art House project tonight as well. It's a new project that was built in Gary, Indiana. So she's working on a number of different and really exciting things. And I'll, just say welcome to Jeana. It's really exciting.
Thanks, Carl. Thanks to everyone for hanging in there for the second last lecture of the semester. I was saying earlier, I don't think I've ever heard so much laughter and smiles in a room full of architects at the end of a school semester, so you must be doing something really right here. It's a pleasure to be here. As Carl mentioned, I'm one of 3 principals in a new practice called Mere Collective, and the 2 collaborating principals that I work with are Kara Boyd and Todd Zima. Here's a sample of some of the projects we worked on together. Many of these are from the start of our collaboration together at Studio Gang Architects, where we worked together for many years, and some more recent work as a collaborative. And what's important to us about this work is that the specific designs emerged out of some of the research that we value into the type of interactions that our clients or communities are trying to promote, and also the resources available. And those resources range from material resource to local expertise to programmatic history. And we think that this is critical to help us create a unique and dynamic architecture. What I'm going to talk about today is focus on a few projects that try to expand the notion of the way we think about material resilience in architecture. And typically, when you hear material resilience in this context, we're often speaking about an interest in the before life or the afterlife of materials. In other words, understanding materials as resources. And for many of us, it's also interesting to think about how advanced computation and CNC tooling can be used to reinvent those resources, maybe in their reuse, maybe in their efficiency. So these are 2 common approaches to this discussion in the discipline of resilience and innovation: material resource and capabilities of advanced fabrication. Another way to think about those frameworks would be to zoom out a bit, to generalize a bit, and describe them as combined interests in physical and computational resources and how they might be thought of in combination. And so much of my early experience in practice, some of which were owed to mentors and colleagues in this room, taught me to use these 2 interests as a leaping off point. and allowed me to think increasingly broadly about physical infrastructures and how computational infrastructures and how these two create a broad context to allow us to consider other goals for material resilience. So today I'll show 3 projects that begin to expand on these objectives. For example, the design-driven manufacturing projects were a series of manufacturing-based collaborations that ask questions like, how can we utilize industry and manufacturing expertise combined with performance simulation? Or how can material microstructure properties be applied to infrastructural challenges? And in the project that Carl was mentioning in Gary, Indiana, called Art House, we asked, how can ideas of material resilience expand to bolster local economies, and how can they create specific opportunities for communities to come together? And then finally, in a project called the Type 5 City, I'm looking at how we can consider the cumulative effect of material patterns, not just through the exceptional architectural experiments that we enjoy working on, but also through the baseline requirements that dictate every building that is built through building codes. So to start with the design-driven manufacturing projects, this interest emerged out of some conversations with a colleague in Virginia. She is an urban planner, and her expertise is in economic development, and we were both interested in looking at understanding our new context a little bit better, understanding what was produced in Virginia, how that expertise might be a resource both for material innovation, but also a way to contribute to the context that we were living in. So we started to do some cataloging of the zones of manufacturing in Virginia, and they vary with the physiography. As resources change, the zones of expertise also change. So for example, in South and Southwest Virginia, there are some production economies that are being phased out, like coal and tobacco, and a need to reinvent those economies. Or in Southeast Virginia, the shipbuilding economy produces a wealth of a different kind of technical expertise. And architects have long had close partnerships with manufacturing. And in fact, we could argue that the only times in history that we really see widespread change in the building industry is when it's an advantage to a manufacturing industry economically to do so. So how do we work in that, with that context, and aiming for that kind of influence by thinking, how do we make this an economic benefit as well as a design benefit? So this, for example, this image shows the testing of frame construction in post-fire Chicago and our testing with local shipbuilding manufacturers in studio. Today's new technology includes simulation, material simulation that allows designers to operate with a constant feedback loop of design options and material response. So architects now have the ability to design material response into our design workflow. And with the proliferation of open data, the inputs can be far-reaching. They can go beyond immediate optimization of things like structures and start to reach into some of these other questions that we're looking at, such as economy or community or resource depletion. This approach targets material resilience by responding to local manufacturing expertise, urban resources, and production infrastructures. For example, we developed this system in close collaboration with a specific manufacturer named Cellular Materials International, and they use some of these bending and welding patterns to create cellular sandwich systems, often applied to aircraft carriers or used for ballistic protection. Their specialty was to use these cellular panels filled with water to dissipate heat when aircraft would take off vertically on ship decks. And so we worked with them to figure out how could we appropriate that technology and think about the use of water and the use of the strength of a cellular system to create an evaporative cooling facade system. So let's see if this works. So in this video, you'll see a specific tool that's called a Cnc Air Break that allowed us to pre-program a variety of bend angles for the aluminum, and the gradient cellular pattern that resulted fluctuates between optimizing strength when the pattern gets more dense and optimizing evaporation when the pattern gets more horizontal to allow the water droplets to stick around longer. So this is the Cnc Air Break. And it was important to, as we were beginning to think about these ideas, to be talking to the manufacturers about what's efficient for you to make, what kind of tools are common in the industry, rather than immediately jumping to tools that are still considered exceptional. Get past this. So the working drawings show dimensions and patterns, also with the functionality of the system. Water is intended to be delivered mechanically and then dispersed through the system while air intake travels through. And here you can see some of the testing of views and densities. This project was a finalist for the TexFab Skins competition and toured with related facade and advanced computation exhibitions. Another project coming out of this same initiative examined the potential use of bamboo as a replacement agricultural industry in Virginia. And it ultimately led for the proposed use of bamboo to combat pollution infrastructures. Bamboo was interesting to Suzanne and I because it grows more than most people would like in that region of the country. And yet we realized, and it's put to many uses, for example, ecologically, it's one of the best carbon sequestration plants. It also is used sometimes to capture toxins in the ground. So we began looking at what are the local or the domestic bamboo production patterns, and we realized that we import almost all of our bamboo, even though it can grow particularly well in the southeastern United States. And the reason for that seems to be the labor that's involved in the current production of bamboo dimensional or engineered lumber. It's a very high labor system that's used to split the bamboo stalks and plane them down and sort them and glue them up. So I ran a studio and asked my students to take those building blocks, those small strips of bamboo, and investigate whether we could come up with a use of this incredible tensile strength of the material without as much labor and without as much density of the material. And the designs that they produced were exciting and inventive, but they weren't quite cracking that challenge of low labor and high efficiency. So it seemed that the pieces we were using, the material itself was just too small to ever compete with the efficiency of the larger building stock that you receive out of lumber. So then I began to think about, well, maybe we're trying to solve the wrong problem. What can bamboo do that wood cannot? If you're trying to create a new industry, how do you find a different type of use for it? And learned that bamboo, because of its dense microstructure, is one of the best toxin adsorption materials. If it's charcoaled, it will naturally absorb toxins in the air and in the water. And particularly if you expose the end grain, you expose more of that dense microstructure. So I began experimenting with different ways to carve the material in order to expose the maximum amount of end grain, and found a Japanese potter who was familiar with techniques of using an outdoor kiln and depleting the oxygen at the right temperature in order to truly produce a charcoal substance. And these were some of the prototypes resulting from that. The proposal, or the kind of idea to launch this, was founded in the idea that we can think about different types of production efficiency. So if we think about this property of bamboo being enough of an advantage to outweigh the labor involved, we could make an argument such as looking at the amount of pollution and statistics for asthma rates in proximity to major highways tells us that statistically, in just the DC-Baltimore clean air non-attainment zone, $132 million are spent on annual healthcare costs just due to the increase in asthma rates. So could we, as architects, start thinking about an alternate argument for material efficiency that's based on health benefits as much as it might be based on efficiency? And in class, I try to bring some of this experience into the studio. For me, I think a lot of the research and development, the important moments in these projects occur not only when testing and prototyping and formulating the ideas, but very significantly in conversation with people with the expertise of working with these materials. And so I've been running studios in Virginia in partnership with some of the local manufacturers. And this is some of the student work that results. These courses combine advanced simulation with intense collaboration. And for me, one of the most valuable aspects, in addition to learning about how to work this way and how to think about performance as an objective, gaining the confidence to talk to people with a different kind of expertise early and often in the design process is an important objective. In the next project in Gary, Indiana, called Art House Gary, we were responding to a competition sponsored by Bloomberg Philanthropies, and we were self-imposing the requirement on this project that we needed to think about how design can add to the material economy in Gary and how it can create specific opportunities for the community in its production as well as its outcome. I worked on this project in partnership with Barbara Brown-Wilson, who is a planner at UVA and also a community engagement expert. Gary, as many of you may know, was founded because of the establishment of the Gary Works facility of US Steel. So manufacturing expertise is plentiful and a source of pride in the community, but it's also suffering from rapidly declining local employment opportunities and increasing levels of poverty. And I'm going to let this video introduce some of the context of the project.
Growing up in Gary was just a phenomenal experience. The city was vibrant, steel and industry was roaring, and as a result, we had a very vibrant community. As I got into my teenage years, as I became a young adult, you saw the economic decline of Gary, Indiana, which was so much more than about economics. It was about politics, it was about white flight, and to see that after being a part of a vibrant city was in many respects painful, but also fueled my resolve to make a difference in the community.
Art House was conceived between a handful of conversations through the City of Gary leadership, including Mayor Freeman Wilson, and an artist based out of Chicago whose name is Theaster Gates.
We were really excited about the idea that artists could help revitalize the city. And the mayor had this building that was available that had an amazing soul food restaurant in it, but she wanted more stuff to be happening there.
Art House combines the culinary arts with public art and community building. We're going to tap into the rich network of artists and creatives to help provide a platform where they can share their works and sense of community with one another. We started with over 40 applicants, both locally and internationally. Barbara Brown-Wilson and Jeana provided us with a very, very strong proposal.
It turns out, Barbara realized in some of her research that Gary was one of the pioneers in ideas about learning through making. So they had a strong educational history that were known as platoon schools, where students learn through a work, study, play model of education. Unfortunately, this tradition has been compromised by budgetary constraints, and arts education has been decreased significantly in the curriculum. So we were interested in finding ways through the production of the competition focus, which was a new facade for this building, to also provide some arts education in the process. So the challenges of this existing building were plentiful. Among other things, thinking about how this could become a kind of beacon for the community. It has very dark windows, so how do you show that there's life and richness through some of that without, with a limited budget for renovation, exterior renovation. In addition, as you may be familiar with this path over the skyline between here and Chicago, this is barely visible. It's just beyond the baseball stadium. So we were interested in increasing the mass and the height enough that it could be visible from the toll road. We were also interested in translating local material and expertise and reflecting the context while infusing inspiration. So I went to Gary once we were shortlisted for the project and started visiting some of the fabricators. I had found a couple and was able to set up a couple appointments, but I had this amazing experience of talking to people, learning about what they made, talking to them about the project, and they would usually say, well, I bend 2-inch pieces of steel. I'm not sure I can help you, but you should go talk to Bob down the street. He works with much lighter gauge material. And Bob was convinced that I must be working for the competition because I was asking so many questions. He wasn't sure why I was there. But it was really incredible to kind of see what machinery had been invented in some of these shops and what kind of production was taking place. And we ended up finding a wire bending shop that typically built small scale things like the bent wire that might hold a rack at CVS, or create a deep fryer basket in a kitchen or a shelf in a kitchen. And we were thinking about how can we utilize this to create a framework to hang art on the building, because we need some sort of infrastructure, and maybe that can even be an infrastructure for future artists to continue to reinvent what this facade, how it operates in the community. And then we were also interested in creating some light, drawing some attention, having it function somehow economically without requiring a lot of energy, having it be visible during the day and at night. So we used a material called Dichroic Film, which changes the spectrum of light as you move around it. It refracts light, different spectrum of light to appear to change color, and just created a really simple lantern out of solar LEDs and acrylic tube and this film. And we thought that one of the fun things was that this was simple enough that people could make their own lantern and bring it home, and if you wrote on the film, it created some really interesting shadow patterns. So we developed and tested and created a mock-up, continuing to develop this in close collaboration with the wire manufacturers. And this was the vision for the project, for the new facade. Some images of the production. We held a handful of workshops in collaboration with a local arts organization for youth to show them what worked and what didn't work about the mock-up that we installed in the building, and talk about public art and have them make their own lanterns. In addition, it was really important to talk to some of the residents who were local, and that was a difficult thing in a competition, to have the time to really do an appropriate amount of engagement. But we were assisted greatly by the owner of the Soul Food Kitchen in the existing building, who was talking to us about some of the cycling that takes place on that route, and how resources for cyclists might be another way to draw people in, and some of the ways in which learning about technology and playing with technology might be a benefit to the local community. So we added this proposal for an outdoor space that we thought could be a good space for events and music, and some of the great kind of barbecues that were already happening during the competition phase. And then during the production of that outdoor furniture, we hired some local help and ran some furniture making workshops as a small form of job training. And so this is the opening day. The University of Chicago Harris Policy Labs conducted an evaluation of perceptions at the opening, and 95% of respondents expressed that Art House is positive for Gary and the region. And many reported that they had never or rarely viewed or participated in public art, but that they would like to participate again. And the part that I thought was really amazing is that 63% reported that it improved their impression of their neighborhood, which seemed like the best metric that you could ask for. So this is the opening event.
We had people who literally gave their blood, sweat, and tears to make sure that this happened. Because we all believe in Gary. We are thrilled to be sponsoring this project because we really do believe that public art has the opportunity to transform cities.
When we started working on this project, we met with a lot of folks who have their own fabrication shops, who do a lot of metal work, and we were so amazed by the ingenuity.
Thanks to everybody that's been involved. It's been a real honor to be a part of this community.
Art has the ability to create a place whereby great things might happen. And my job was to simply create the conditions by which great Gary people could do great things in Gary. And I be darned, great things are happening tonight.
Didn't have architectural or furniture scale work in their portfolio previously, but have since worked with other architects and designers to expand this part of their business. So finally, the last project that I'll show briefly is a research project called the Type 5 City. And this is the one that I mentioned as an interest in, it began for me as an interest in this type of work, but also in why it's not more widespread. Why is there not more experimentation in the way that we build and the way that we use materials in architecture? And so I just became curious about what are the infrastructural, regulatory obstacles, financial obstacles that keep us at kind of one level with using one kit of parts with most of the constructed environment. And so I began digging into codes a bit further and became interested in construction types in the International Building Code. And these are categories, as many of you know, that evolved in the early 20th century to rate levels of combustibility from the highest level of protection, type 1, to the non-protected combustible, type 5. And they're kind of an anomaly in the world of construction codes because, like most building codes, they deal strictly with regulation within the lot line, but unlike most building codes, they're actually fundamentally trying to control an urban scale performance, not just the building scale. And this is typically more the realm of zoning code regulation and less building code. So I thought this was pretty interesting to consider cumulative urban scale impacts of a material by a neighborhood or by a city. Unfortunately, they're only looking at one very particular performance criteria, which is combustibility. So I've been asking what other types of material performance might have an impact on cities. So material properties like embodied energy, thermal diffusivity, resource geographies, resource stock, durability, lifespan. These are some of the elements that are left out of that equation. And other assumptions, other problems with the model of the building code are a static environment that it's responding to, not considering a cumulative effect, what's happening in the neighborhood, what are the rest of the surrounding buildings built out of, what's happening in the region, what are the resource limitations, and even how do we consider performance beyond a 4-hour period? So when materials are rated, they're rated 1 hour of protection all the way up to 4, but what happens if we consider a much larger lifespan? So in other words, if we think of building codes behaving more like computer codes that have rules responding to input data, suddenly we can think about how architecture can meet one of the primary dimensions of resilience, which is the ability to adapt. And these are some, what I call the fingerprint of cities that I've been collecting from the offices of the city assessor, which is the type 5 construction in yellow and the type 1 construction in gray. And there are two primary hypotheses here. First, that the impact of material building stock on urban resilience is a particular blind spot in building regulation and in the larger discourse of resilience and environmental justice. And second, that as vulnerabilities inherently change, so much the criteria that we use to analyze responses. Performance-based code is not enough. We also need contingent code or associative criteria. Here are a few initial findings. And what I'm aiming to show here is that aggregated material performance has a relationship to other types of material vulnerability. In these maps, type 5 is yellow and type 1 is blue. And each is highlighting a different risk, a different correlation that's not necessarily causal, but a correlation that now I'm trying to dig into further and say, well, how might there be a relationship here between this vulnerability and material? So foreclosure rates follow the material pattern pretty closely in New York and Chicago, as do vacancy rates, as do blood lead levels. But the correlation is also not always easy. It's not enough to just say, well, more vulnerable construction is always the answer. Of course, there's other kind of ecological considerations and changing climate considerations. For example, there's a high correlation between heat wave deaths in Chicago and heavy thermally absorptive construction like brick. And the final piece I'll talk about today with this project is that I'm also finding that material policies and standards that are set in motion have a long-lasting impact. For example, the map on the left shows the fire limit boundary, and the dark dotted line is the fire limit boundary that was set immediately after the Great Chicago Fire in 1872. And what I found is that inscribed a material pattern that is still present today. It later predicted the rates of land value appreciation, that line. It predicted the redlining investment guidelines later in 1932. And those lines are still visible in today's material landscape. Some of the other cities that I'm studying are Phoenix, Tampa, Denver, and the most uniform, Los Angeles. So some of the takeaway questions or takeaway considerations are that material resilience in architecture, I believe, requires us to constantly redefine the problem in order to see new opportunities or new relationships. Sometimes that means zooming in further to study material properties, and sometimes zooming out to study geographic resources, economic needs, and policy goals. And I'm happy to take any questions. Thank you. You were lining up the questions, weren't you?
I really admire your lecture.
Thank you.
I'm kind of speechless. Can't really say anything. No, I'm speechless. No, actually, I told my friend who's streaming right now to.
There's thousands of fans on the internet.
I know. I actually told one of my friends online to ask a question on my behalf, just to get back at Carl. But, really, I just want to commend you about your thoughtfulness about the different scales that you're working with materials, just like what you just said about,
Thank you.
The broader perspective, which is the geographic, and zooming in into actually the materials experience. My question to you: how would this inform architectural education?
That's a good question. I think for me so far, it's been this aim to encourage students to work with other disciplines, and not necessarily only in a prescribed way, because sometimes we do that and, while we bring someone in to consult with the class, but in terms of if you have a question, let's figure out who can answer it for you. Is it someone on the material science faculty, or is it a local fabricator? And one time, one of those groups of students was interested in acoustic performance, and we found someone at Virginia Tech who's an acoustic expert and called him up, and they were saying, could you just give us a Skype crit? And he said, oh, actually, I'll come talk to you. I'd love to talk to your class. And he gave us this really fascinating lecture on how to design with acoustics. So I think that is one way that we can start to breed some of this kind of curiosity in architectural education, or perpetuate it.
May I ask another question?
Sure.
The last one, sir.
All right. So you brought up this notion of Gary
Yes.
in Indiana, that they have this school where they believe that you learn through making.
Mm-hmm.
Now, do you think that this idea of like exploring materials as well as enhancing material performance can be actually done within changing dynamics of architectural studies, as in like architects are not only designing anymore, they're actually doing the whole process of start to finish. What do you think about that?
You mean designing and fabricating and?
Yeah, so almost like design and build, but in a way there's research behind this, just like with this skin competition that you've done.
Yeah, I mean, it's a good question. I think for me personally, I found that there was so much to keep up with in terms of how quickly the fabrication technologies change, even in terms of asking my students to ramp up from, maybe just using the table saw for the first time to trying to get to a point where we're doing cutting edge research. I felt like we needed to rely on the experience of people who really were bringing a higher level of expertise if we wanted to get further. So personally, I like to have that balance as opposed to trying to do the whole every step myself. But I think it's a matter of learning what questions to ask to try to, I do think that within education, it's very valuable to go through a lot of the kind of prototyping and learning how to use the machinery. Even if it's just so then you know what questions to ask, because you run into some of those problems. You know how to say, like, well, where's the back gauge on this machine, and what dimension can you accommodate, and how can I create a datum for you to easily know how to set it up. And that takes, I think, working through that process yourself to get to even know what questions to ask.
Thank you very much.
Yeah.
I'll email you more questions.
Okay.
No, seriously.
Okay.
Because Professor Jim said that's my final question.
Does anyone else have a question?
Thank you very much, Jeana. I guess I was thinking a little bit about the things we work on, or maybe the things that we have access to, or the tools that we have. And you didn't, I mean, it's great to see the work, and you're not necessarily disclosing the way that you're working on some of these things or talking about them, but I was thinking, I see a lot of what I think is GIS in the background in terms of some of the things that you have, and maybe even to pick up on Safi's point, that the range of scales that you're looking at is pretty amazing, from the detailed scale to the scale of an entire city. And is your ability to do that because now you have access to that type of data or those types of tools? And how did you learn those tools, or why did you learn those tools? And is that changing your practice maybe?
Well, I think I remember an independent study where you said, you're a computer scientist, why don't you do some coding and I'll help you do it. So that's why I learned it. Carl told me that I should. But no, I think that I, at some point, was feeling a little bit of a frustration about how we talked about data and computation and architecture, because I felt like we were so focused on just what we were making and what it did to the building, and yet we have, you know, all of this data about everything, about like who is working and like who are the laborers and what's the, you know, what's the material pattern, but it's not necessarily, it wasn't feeling like a prominent part of the way that the discourse that I was exposed to in the kind of computational framework. I went, when I first got back into teaching, I went to my first computation conference, and I was really excited about it. And then I realized at some point, no one is talking about human beings in this whole conference. There's no mention of people, and it felt like, I mean, that's what I mean by a frustration with like what the scope of questions that were being asked. And so I'm still learning GIS. I rely heavily on a superstar research assistant who has gotten really into it. But I think it's just been a matter of, in terms of how we try to teach these tools, it's a challenge, because I feel like the best thing we can teach is how to be nimble, and that's not necessarily what students usually want to hear. They want to hear who's going to give me my workshop and tell me exactly what I need to know. But I think what you need to know is how to learn new things.
I'm really fascinated by this last study about materials.
Oh, thank you.
What got you onto that? And it's a huge, broad subject matter. So to take that on, are you working with a group of people, or is this something you've sort of been pursuing on your own with maybe the help of your superstar research assistant? But I guess what generated you taking this study on, and where do you hope to go with it?
So I hope to publish a book next year on this, and I've been working on it for about 3 years because it's taken me that long to figure out how to even rein it in. And it's taken me a long time to get the data. Most of the cities, I mean, they have this data, but I have yet to encounter any city that publishes it as part of their open data offering. So it's often not even the city, it's the county. And to my surprise, it's not even the fire department. I thought for sure the fire departments would have this available, but they don't. So it took a while to figure out who to talk to and how to put in the FOIA requests. And so now my goal is to, as a way to just pull it into a manageable format, to say, if we just take the model, if we think of the code as a type of model, and we just look at what's missing from the model, cumulative impacts, time, a broader time scale, an assumption that the environment is static. And so I'm going to try to organize the conversation according to those missing pieces, and then dig into that further. But I could, I'd be happy to have some crits. I keep asking friends to let me run this past you and point some, pick it apart a little bit, help me think it through. A friend and I last year went on a kind of little writing retreat together, just as a way to have focused time, but also to bat around ideas that we were struggling with, and that was really helpful also. She's written about building codes, so more from a kind of theoretical perspective, but that was very helpful to me.
So Jeana, I love this slide, and it's making gears turn like crazy. And I wonder, I'm not even sure exactly how to pose the question, but I'm going to try. One of my frustrations in practice with the building code is it's not necessarily so difficult to follow the code. It's sometimes difficult to know the intent of the code. So you can read it and intellectually understand what the line in the code means, but how that is intended to be implied in a given situation is what was for me. I didn't have issues with building inspectors. I had issues with the building inspector and I trying to come to terms with what was intended by the actual line. And when I look at this, it makes me think that most of the scenarios when that came up was contextual. It was like, maybe it was written with the assumption that the building was in the city, but we were dealing with the city in a rural area, or vice versa. And I wonder, now that we have this ability to accumulate data that's contextual, in other words, we can know if enough coding's done, we know a lot and the intent of that code on that lot based on its context, its environment, its adjacencies, its floodplain, everything. So would it be possible, and right now you're right, it's like we start with that type construction based on combustibility. Fire is where it begins. Is an outcome in the long run, not for your book, not the but is it possible that we may move to the International Building Code, which is a single document that governs an incredible amount of land area and contextual conditions, that we may be looking at something that's more geolocated?
That's my hope.
Yeah.
It's what I'm struggling with right now is how do you take that back into something that resembles the scale of the building? Is it a matter of rethinking the components, rather than just saying material is based on occupancy? Do you need to say, well, let's look at it in section instead of just in plan? And because that's another piece of it, is that the building types have a section to them, particularly now with the 5/1. It's like we're creating a new material, a new layering of material deposits by virtue of the fire code.
Right.
So I'm trying to get to that point eventually where I could start to propose an alternative of how this could look. And then the next challenge, I guess, would be to say, well, now apply that to the city again.
Right.
What does that look like?
It's an incredible challenge, but I think one that has to happen eventually.
Questions? I have one. First of all, I want to echo a lot of the compliments paid to you, the range of the work in terms of what is considered, as well as what the implications of that consideration might be. As Jim said, my mind is racing. I also appreciate, it seems like you were incredibly dutiful within the slides that you identified the source of material. So in this instance, it's you as a person, and then there are other instances where it's mere collective, and then it's other instances where it's Ripple Architects, and it's other. And I wonder how using those multiple frames, organizational frames around your effort has helped you deal with or grapple with this really vast network of considerations that you're making? Assume it wasn't random, at least. You were just throwing a name up there. You were like, okay, this is a moment where it's me, right?
Right. Well, because that is a really important, I'm glad that comes through, because those collaborations are really important, and it's at all levels, from students who might work with me, who I want to acknowledge, to other collaborating faculty, to design collaborators. I think it's for me a more enriching way to work, and I think those multiple frameworks are what's exciting about being in an academic environment, that there's a little bit of freedom to be involved and to let your work have these different elements to it, that there might be a kind of research project that's moving slowly and in the background at the same time that there's the deadlines of practice or opportunities that pop up in a competition.
So let me rephrase in another way. Thank you. Do you ever take a project from one entity into another, or find it shifting?
Oh, I see.
Or thinking after the fact, shoot, that should have actually been run through this entity as opposed to this entity? Because I know you're just one person, right? But you also have the ability to tap into these very different networks of support, right? And in the answer can be no, that never happens.
No, that's a good question. I mean, I think more than that, I wish that I had all the time to work on, to be that fluid about the work. And sometimes it's more limited by the time I might have with my business partners. And I would love to talk to them more about this work, but we're too busy with other things, and vice versa. But I think I think the ideal scenario would be to have it be much more connected. Yeah.
Give someone the final word, because I certainly don't want to take it. Is there a final question? Thank you.
Great. Well, thank you very much for this beautiful work and beautiful graphic as well. I have a question. In your first project, you talked about different patterns and then also the bamboo. Is this project still under research? Do you have anything to add and elaborate on that?
That one is probably one of these latent projects that I'm hoping will come, an opportunity will come up to use it, to apply it at some point in practice. I reached a point where I was looking for some collaborators in environmental sciences, and we were talking about how we could get a grant to actually test the different fabricated pieces. And I just kind of ran into a limitation of time, and I've let it be dormant for a while. But a colleague who I've been working with on a journal project, who teaches at University of Kansas, saw that and called me and said, we're doing I think it's a project in Haiti, and could you tell us about this? And I was really happy to think that somebody else might pick it up and push it further, because I think it's interesting to me, and I just haven't had a chance to pursue it much further than that.
Thank you. I'll join you.
Okay. Great.
Well, thank you very much again for coming.
Thank you.